This R2R digital to analog converter converts the digital input of 9 volts to an analog output with a value from 0 to 255 256 of 9 volts. Each switch contributes a fraction of the 9-volt input, starting from 1/2 to 1/4, 1/8, 1/16, all the way to 1/256. The total voltage contributed is shown on the voltmeter screen. This is the breadboard prototype of the circuit board, with the total voltage measured by the brightness of the LED. We see the resistor ladder connected to the switch bank. Since this starts with every switch on, as each switch is flipped, the total voltage decreases and the LED gets dimmer. This diagram showcases how Thevenin's theorem is used to simplify the resistor ladder, shown in this small-scale schematic. For this to work, we consider all inputs to be off, leading straight to ground. The first two resistors have the same resistance, being 2R, and are in parallel. They can simplify into one R resistor, as shown here. These two R resistors are now in series and can thus be added up to be 2R. The two 2R resistors can be simplified again into one R resistor, and the cycle continues. Eventually, the circuit comes here. These two 2R resistors are simplified into one R resistor, and we are left with the Thevenin equivalent circuit. To calculate the voltage contributed by each bit, we use superposition, made possible by simplifying the circuit. In this smaller scale diagram, the most significant bit is bit 4. If the input is 9 volts, we see that half is taken to ground, while the other half is the output, resulting in an output of 4.5 volts, or 1/2 of 9 volts. With bit 3, we see that the 9-volt input is divided into 4.5 volts and divided again, resulting in an output of 2.25 volts, or 1/4 of 9 volts. Each bit divides the 9-volt input once more than the previous bit, adding up until the final bit on the circuit board outputs 1/256 of 9 volts. The R2R digital to analog converter is a perfect example of digital to analog conversion and how the voltage input is divided into an analog output.